it turns out that you can't understand the fire ants without understanding how they move in confined tunnels. We watch them move around in tunnels they make in the laboratory and for which we can observe them. We see very interesting aspects of the climbing. Slips and falls and bumps into the sidewall are kind of the rule. And that seems to be the biggest scientific point we found. So whether they're ascending or descending, they seem to slip and catch themselves quite frequently. You know, we shook the ants in Nick's apparatus and found that they tended to be very stable as long as, meaning they could catch themselves from fall, as long as they were in tunnels that were comparable to what they create in the natural environment and even smaller. So that's cool. But we had only observed the tunnel creation in these kind of scientific ant farms, which, you know, are ant farms, so it's not clear that that's the kind of tunnel one makes in the real environment. So the third aspect was to actually see what size tunnels they make. And they don't just dig in one kind of soil, as Nick probably told you. These animals are just incredible. They have invaded the bottom third of this country and have done so by digging and creating these beautiful, complicated nest structures in a diversity of soils, from clay particles, which are tiny, to big sand particles and big compared to their head. And so Daria and Nick then basically put these ants in containers and made them dig, and then recorded the amount they dug in the diameter of the tunnel. They found the amount they dug did depend on the amount of the type of soil that we put them in, but the diameter of the tunnel was always the same. And it was always the same, basically, as that in the scientific ant farm experiments, and that's the tunnel size, which they seem to be stable as long as the tunnel was smaller. Then they would lose stability if the tunnel got much larger than that. What we think and what we hope is that the kind of principles, and this is the key idea, the principles by which organisms manipulate complex environments can be kind of distilled and brought to bear upon challenging robotics questions, because the state-of-the-art of search and rescue robotics is in fact quite limited. A lot of the materials in disaster sites, landslides, rubble piles, are loose materials, which you're going to have to either squirm through or potentially create structures out of. You know, you might want to create a temporary shelter for people buried down beneath, and that you might want your robots to do that. But how do you pick up a bunch of rubble and place it in the right way such that the whole thing doesn't collapse? The animals, these ants, I should say, they can make tunnels in or nearly dry sand, which I can't poke a hole in as hard as I try. The hole will collapse. But the animals create perfectly fine structures. So how the hell are they doing it? We don't know that yet.